Namaskar everyone. Indian Master Ji welcomes you to this YouTube channel. Today we are going to learn about continuous random variables. We will see how it is represented, how it is defined, and certain other things. But before we start, a small request. After watching the video, if you find that the video was useful, then please like the video. Help your friends and other students who also are in need of such useful contents by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on this channel. So let's begin with today's video. Suppose I say that I have a fair cubical die. Okay, I have got a fair cubical die. And I roll it once. And I try to find out the score on the upper face. Score on the upper face of the die. Score on the upper face. Of the die. So what all values can I get? I'll get something as 1, 2, 3, 4, 5, 6. Correct? I can have only these particular values. If you see, these values are what? These values are precise values. 1, 2, 3, all these values are what? These are precise values. Correct? And if I ask you, what is the probability of getting 1 on the upper face? You will say that if the die is fair, then the probability of getting 1 is 1 by 6. Similarly, the probability of getting 3 on the upper face is 1 by 6. The probability of getting 6 on the upper face is 1 by 6. So that means these specific values, these precise values, have their own respective probabilities. Here in our present case, the probabilities are the same. Correct? But it's not necessary that the probabilities will be same for these precise values for some other experiment. But because these values are precise, these scores are precise, these precise scores we can represent by something called as a discrete random variable. Like I can say x is a discrete random variable which represents nothing but the score on upper face of the die. Okay, so here what is my x? X is discrete random variable. Okay, now these values I'll represent by a small letter x, and this discrete random variable can take any of these particular values. Correct? So if I say what is the probability of x taking a particular value small x, you will say if small x is 1, then the probability of x taking a value 1 is equal to 1 by 6, and so on. Correct? So in turn, what we have drawn here, what we have plotted here, or in fact what we have tabulated here, we have tabulated the probability distribution for the discrete random variable x. Correct? So any discrete random variable can have its own probability distribution table like this. Now let's take another example. Suppose if I say that my mass is 60 kgs and it is measured to the nearest kg, measured to nearest kg. So can I say precisely that my mass will be 60 kgs? No. My mass can be anything between 59.5 kgs to 60.5 kgs. Suppose if I represent my mass with the letter small m, so m can take a value between 59.5 kgs and 60.5 kgs. 60.5 kg not included. This you might have studied in the lower grades also. Okay. This is the lower bound and this is the upper bound. So I am not able to give my exact mass, precise value. Okay. My mass is been defined in a particular interval here. So my mass or mass of any person can in turn be represented by something called as a continuous random variable. Okay. So mass basically is nothing but an example of continuous random variable. Similarly, suppose if I say that I want to find out the waiting time before I can get a next bus from the bus stop where I am standing. So the waiting time again will be a continuous random variable. Similarly, if I have to measure my height, so my height, if I say it is 150 centimeter, correct to the nearest centimeter, then again it's not the precise value. My height can be between a particular interval. Okay, so that means the length also is nothing but a continuous random variable. So these are examples of what? Continuous random variable. Okay. So if x is any continuous random variable, how do we define it? How do we represent it? Let's understand that. So basically, any continuous random variable, suppose if x is the continuous random variable, then this continuous random variable is defined by its something called as probability density function. By its probability density function. Probability density function. Okay, f of x. And how it is represented? Basically, it is represented in the form of graph or illustrated in the form of graph. Form of graph of what? Y is equal to f of x. Okay, let's see an example on this. What I mean, what I'm trying to say here. So if x is any continuous random variable, then its probability density function somewhat may look like this. Not necessarily this specifically, but somewhat like this. This is what? This is a graph. Okay, graph with certain interval. Okay, if you see here, these values are not there. Let me just erase this, or let me enlarge and then erase. so that you all understand what I'm trying to say. Okay, so what I've done is I've tried to draw a probability density function f of x, where this random variable, continuous random variable, is taking certain values x. Okay, and this probability density function is defined only for certain values a to b. For the rest of the values it is not defined. So if for the rest of the values it is not defined, so how do we represent? We represent by a line on the x-axis, which means that these values are 0. Okay, so here this f of x basically will be an equation, correct? So here I can have something f of x as equal to, say, 2x plus 2, okay, defined for an interval. Now what is the values of x it is taking? It is taking between a and b. A and b will be some constant, correct? And f of x is equal to 0 otherwise. For the rest of the values of x it is not defined. Hope you have understood till here. Okay, now if I ask you that what is the probability that x lies in a specific interval, like suppose, let me draw another graph, or let me take the same particular graph. Okay, and I say I want to find out the probability that x lies between x1 and x2. Okay, so I am taking two values, x1 and x2, and I am trying to find out what is the probability that x lies between x1 and x2. So how we will find this one? Probability of x lying between x1 and x2. I have to find out this. So how we can find out this one? This is nothing but the area under this graph. This area is nothing but this particular probability of x greater than or equal to 1 and less than or equal to x2. Okay, so this is, I can write it as, this is equal to area under the graph of f of x. Okay, between x1 and x2. How we can find out this particular area? So the area can be calculated using integration. You might have studied in pure math 1, can be calculated using integration. Or geometry. We will see how we can use geometry also here, using integration or geometry. Okay, so that means I can say probability of x lying between x1 and x2 is equal to integration of f of x when x is varying from x1 to x2. Okay, hope you have understood till here. Now let's try to understand certain properties of this probability density function. The first thing is that this f of x is basically defined for all real values of x. It is defined for all real values of x. All real values of x. But what is the value this f of x can take? F of x can take a value equal to 0 or greater than 0. What does this mean? Equal to 0 or greater than 0? It means that graph of f of x, cannot go below the x-axis, or in short cannot have negative values. Correct? Why? Because probability is always greater than or equal to 0. Correct? The minimum value of the probability is 0. Probability is always greater than or equal to 0. And what we are trying to find out? We are trying to find out the probability. By finding out this particular area, we are trying to find out the probability only. Okay, so probability can't be negative. We also know that the total probability is 1. Sum of all the probabilities for the random variable x taking any possible values between the interval in which it is defined, the sum of all the probabilities is 1. Correct? Since total probability is 1, this means if I try to find out the integration of this f of x, okay, for all real values of x, means from minus infinity to infinity. Even if it is defined between a and b, for the rest of the values, it is what? It is defined as 0, correct? For values less than a, it is defined as 0, the probability is 0. For the values greater than b, it is 0. F of x is 0 here. Correct? So that means if I try to find out the total probability, so that means this area under this graph as well as the areas to the left and to the right, if I add up total areas, the value will be equal to 1. Or in short, I can say that the total area under the graph of f of x is equal to 1. Why? Because the rest of the values there is no f of x. So there will be no area only there. So I can say total area under the graph of f of x is equal to 1. Correct? So we have understood these two things. Let's try to understand better using an example. Let me take another page. Okay. Now suppose if I draw a graph somewhat like this. F of x versus x, and I draw a graph like this, and I ask you whether this graph represents a probability density function. I'll give certain values also for x. Suppose here x is 0, here x is 1, and this value is 2, and here this value is say -3 and this value is 3. So if I ask you whether this graph represents a probability density function, then the answer is no. Why? What is the reason? We just studied that the graph of f of x cannot have negative values. It can't go below the x-axis. graph of f of x cannot have negative values. Okay. Let's take another example. Suppose if I draw another graph of f of x versus x. The graph is somewhat like this. Okay. I'm just trying to keep the boundary here. Let me say this particular value is 5 and this particular value is 10 and this is 0. This is graph of f of x, and I ask you whether this graph represents a probability density function of some random variable, continuous random variable x. So here the graph is above the x-axis. That's very much clear, evident here. But we also know that for a probability density function of a continuous random variable x, the total area under the graph has to be equal to 1. If you see this particular graph, this graph is nothing but a triangle shape. So the total area here under the graph, can I find out using the area of the triangle ka formula? That means I am trying to find out using geometry. So can I say the total area is nothing but half into 5 into 10 here? So what do I get this area as? I get this value as 25, 2 5s are and 2 1s are, and we get 5 into 5, that is 25. The total area here is 25, but area under the graph represents nothing but the probability density function. For a probability density function, this area has to be equal to 1, correct? Here it is coming 25. So that means this graph doesn't represent a probability density function of a continuous random variable x. Correct? Let's take another example. Okay. This is again some graph of f of x. This value is 1 and this value is 2. This value is here 0. And I ask you whether this graph y is equal to f of x represents the probability density function of some random variable x, continuous random variable x. So we will check two things. Here the graph is defined between 0 to 2. So and it is, the graph is above the x-axis only, positive x-axis. It is not going below the x-axis. Let's try to find out the area. Again, this graph represents what? A triangle. So I can find out the area using the geometry here. So can I say this base is 2, so half into base into height, 2 into 1. So what do I get? I get this as 1 into 1, which is 1. So that means the total area here is 1. So that means the probability is equal to 1. So yes, this represents a probability density function of a continuous random variable x. Okay. Now certain few points more. Because we are talking about a continuous random variable, and we know that it's very difficult to get a precise value for this random variable x. So that's the reason this probability of x greater than a less than b is equal to probability of x greater than or equal to a less than b is equal to probability of x greater than a and less than or equal to b is equal to probability of x greater than or equal to a and less than or equal to b. All these probability values are the same. So does it mean that x cannot take value equal to a? No, it doesn't mean that. What it means is that probability of x equal to a is equal to 0. This means that x can take the exact value a. X can take exact value a. But the probability that x takes the exact value a is 0. But the probability that x takes exact value a is 0. Okay. So these are certain things which we need to understand about continuous random variable. If we have understood this, then we can take an example on the same, which we will take in the next video. That's it for this video. Hope you have found the video useful. If yes, then please like the video, help your friends and other students who also are in need of such useful content by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on the channel. Comment what was good and what can be improved. And finally, till we meet in the next video, stay healthy, stay blissful. Radhe Radhe.